Something I think a lot of people might not realize is that the best tech stories you read on hackernoon.com, right? They're not written by professional journalists. That's one of my favorite things about this job.
I am a software engineer.
I'm a systems architect,
founder and CEO,
director of cultural strategy.
I'm a junior product designer.
I'm the head of corporate affairs,
CEO and co-founder,
senior manager of data sciences.
For the series you're listening to right now, episode 4, I think, I asked a bunch of Noonies Award-nominated HackerNoon contributors a series of questions about living and working in our big, bad internet world. In this episode, 5 answers to the question, how do you go about
solving problems like a developer?
And
can you outline your general framework for approach to solving problems?
I'm Natasha Nel, you're listening to the HackerNoon podcast. Here's how to solve problems like a software developer.
There's a tendency in software to jump too quickly to solutions.
Don't jump at solving it right away.
One needs to find the why of the problem.
Try to understand the problem. I really want to make sure I get it.
I try to figure out what the motivations are behind any problem.
If you can kind of use your creativity and your imagination.
Give yourself a large canvas.
Now, if a problem is big enough, I separate it into small chunks and try to solve them separately.
To break the problem into smaller problems.
Then try to break it down, decompose it into smaller problems, into smaller tasks.
Figure out the connections with other problems that I've seen or solved.
And then go test your hypothesis.
But you have to be clear that what you're putting out there is not final. We have to stay open-minded about choices of solutions.
We need to understand if it's really an important problem.
And also about which are the most important problems.
So what you heard there was the TLDR version from 5 of the top HackerNoon contributors who answered this question about their approaches to problem solving. There is so much more goodness in their responses though, so stay tuned for the full recordings or check out the timestamps in the description if you want to skip to something specific like agile or the Moscow method or an example of problem solving that's a little close to home, Alexey. Just saying. And now, with gratitude and in order of appearance, I present to you Rishabh Anand, Ryan Dawson, Paul Bailey, Aditi Bhatnagar, and Alexey Grigorev.
In my room, I have a whiteboard I always sit in front of when problem solving. My name is Rishabh Anand, and I am a machine learning research student and current undergrad at the National University of Singapore, and I have been nominated for Contributor of the Year in the Cloud Computing category. I am a heavy visual learner, so where possible, I try to draw diagrams and sketch things on scraps of paper lying around till I find a solution to a problem. In my room, I have a whiteboard I always sit in front of when problem solving. A general tip I'd like to give is to give yourself a large canvas when solving problems. You don't know when you'll get that next wave of inspiration. So best be prepared for when that moment arrives. This could be, having lots of blank sheets of paper around you, a tablet to draw things, or like me, a whiteboard to scribble stuff. Sure, not everything can be made into a diagram. A common and well-known approach I take is to break the problem into smaller problems and solve them one by one. I then lay these smaller sub-solutions together to solve the original issue, kind of like a big picture. The simple task of listing all these sub-problems instead of juggling them all in your head will definitely go a long way in making your life easier. Usually when you have a lot of things floating around in your head, you tend to overstate the problem, something where you feel really overwhelmed. By listing down the specifics, you're essentially boiling it down to the bare minimum. It looks so much more manageable on paper. Now all you need to do is go down that list and scratch an item off one at a time. Every person has their own way of approaching problems, big or small. Though my best word of advice is to find your own balance instead of trying to emulate someone else's problem-solving methods. Finding your middle ground really streamlines the way you work and even makes you more productive. You won't feel like you wasted any time at the end of a problem-solving stint, regardless of the stint being successful or not.
I try to figure out what the motivations are behind any problem. Normally there's business objectives that are the real essence of the problem. But typically problems don't get presented that way. Often somebody already has a solution in mind. Once I've managed to get a sense of the business objectives, then I look at what tools I could put together to best meet the problem. From there, things can go different ways. Sometimes I have to try building something before I realize I've overlooked something. Other times a good solution just jumps out right away. Sometimes I repeatedly go back and forth between understanding the objectives better and sketching an approach. There's a tendency in software to jump too quickly to solutions. I like the agile idea of getting partial solutions out there in order to get more feedback and improve. But you have to be clear that what you're putting out there is not final, and know how you're hoping to get feedback so that you really can learn from it. We have to stay open-minded about choices of solutions, and also about which are the most important problems.
What is a general framework or approach to solving problems? Hi, this is Paul Bailey, and I'm a systems architect at Cognitive Space, and I've been nominated for the Contributor of the Year in Database, and I wanted to answer the question about solving problems like a developer. I want to talk about debugging as a programmer, and I want to go over kind of two frameworks. One is really simple, and the other is a little bit more abstract, but they're both really important. The simple one, let's go over that first, is just simply reading log messages. I can't tell you how many times I forget to look at my logs, and I spend hours of time trying to debug something, and the log is shouting at me the precise location and the thing I must fix. And I do this still after years of experience. I'm better than when I was a junior developer. And, I've taught junior developers, and it's a discipline that you have to remember that, okay, step one, read my logs. And so it can really help you to debug a program. The second thing I want to talk about is more abstract. In the book Ender's Game, one of the sequels, there's a artificial intelligence called Jane. And Jane becomes so powerful that she can kind of simulate or understand anything in her mind in terms of like understanding how objects, atoms interact with each other, or the molecules of something interact. And with this power, they're able to make a ship, which is basically a box, stick some people in it, and because she can understand every atom and every interaction in that box, she's able to transport them to another location in the universe instantaneously. And I feel the same kind of thing comes to developers when they understand their code. If you understand your code well enough, you can see a bug come in and imagine how it might occur. So think of the scenarios, the failure scenarios of how something might fail in that manner and produce that message, and then be able to go fix it. And this is something that, it doesn't come instantly, or even with, in particular, on a particular project with years of experience. You have to also have the experience of developing, but also the experience in that code base. And experience working with that code. But eventually, once you kind of build up your knowledge base, and if you can kind of use your creativity and your imagination to think of how that error message might have occurred, and then go test your hypothesis. So put in debug statements, or use a debugger to basically verify how you imagine that might have happened. And just kind of sitting there thinking about the whole code base and how it kind of fits together, it can help you debug something faster. And so that's my 2 frameworks for debugging. This has been Paul Bailey. Thank you.
Before doing the research, it's very important to have a clear question in mind that you are looking an answer for, and then just keep digging. I'm Aditi Bhatnagar, nominee for HackerNoon Contributor of Year Award in Technology. So the question is what's the outline of my general framework or approach to solving problems? Now that's interesting. I think the first step is to fully read it. So that is very important, that you give enough time to understand what the problem is and not jumping into the solutions or linking it to something. Right? So one needs to find the why of the problem. What is it that we are trying to solve? And once you have given it enough time, then the exploration starts. Now, either it can be like a known problem where a solution already exists and one can always improve or build on that. Otherwise, it's an unknown problem. Now, if a problem is big enough, I separate it into small chunks and try to solve them separately. I'll figure out the connections with other problems that I have seen or solved. For completely unknown or unseen parts of the problem, it's time to do some research. Before doing the research, it's very important to have a clear question in mind that you are looking an answer for, and then just keep digging. Try out, build stuff, some samples, and over time you start getting clarity and ideas of probable solution. It's also possible that while you're doing this, you uncover a lot of challenges. That often happens with me, and a lot of new problems are there in the process. And I follow the same strategy for these newly discovered problems then, and eventually with time, efforts, and trials, I have a decent solution at hand. The process can be repeated for several iterations, and it gets refined. So yeah, whatever it takes until it gets solved.
One thing I like to use is the Moscow method. Can you outline your general framework for approach to solving problems? First, I try to understand the problem. I really want to make sure I get it, and I don't jump at solving it right away. After making sure I understood it, I stop and think about it. I ask myself, is it an important problem to solve? Should I even bother solving it? And to answer this question, I need to do some initial analysis. Or maybe talk to customers, talk to stakeholders, and pull out some data, back it up with data, try to analyze, to understand how many customers are affected, what is the downtime because of this problem, or how many people are complaining. And once you confirm that this problem is indeed an important one, then try to break it down, decompose it into smaller problems, into smaller tasks. And I try to use the 80-20 rule to identify the most important parts of the problem. I try to understand how we can solve the problem in a way that doesn't require a lot of time but brings a lot of value. So when breaking it down, I try to focus on the most important parts and do them first, and improve iteratively. So do the most important thing, then understand if it indeed solves the problem, and if it does, then do the next important thing, then the next important thing. But if it doesn't, then try to understand why it doesn't work, what went wrong, what should be done better. Maybe we didn't understand the problem well enough. Maybe we weren't solving the right problem. We were solving something else. Adjust it, learn it from this experience, and repeat. Now, for example, suppose we have a platform where people publish blog posts, something like HackerNoon. And then people start complaining about duplicate posts. Or people say, hey, I wrote this post, but somebody else just copied this post and pretended that this is their own post. We need to understand if it's really an important problem. Is it just one incident, one isolated case, or there are many cases like that? We can do this by either analyzing complaints from our clients, our users, or maybe just pulling last 1,000 posts and manually just going through them and seeing how many of them are duplicates, are copies of other posts. Let's say if we identify that just a few of them are duplicates, then maybe the problem is not that important and we don't really need to solve it by building something. We can just solve it manually by just going there and removing it. But if we identify that 10% of our content is duplicates, then we indeed have a problem, and we can start decomposing it. Let's say we can say to detect duplicates, we need to index all posts. Then we need to have a way to communicate to writers that this post is a duplicate, and things like that. Then once we decompose this problem into smaller chunks, we can prioritize them. One thing I like to use is the Moscow method. So Moscow, basically, for each task, you say if this task is a must-have task, it really needs to happen. Or it's a should-have task, which is nice to have, but not that important. Or it could be a could-have task, like something we could have, but it's not that important. And then we basically assign each task must have, should have, or could have, and we see this gives us a way to prioritize our task, and then we can focus on must-have ones. Let's say we determined that indexing is a must-have thing. We really need to have it to stop duplicates, and the rest are should-haves or could-haves, and then we just don't work on them. We focus on indexing. So we work on indexing, we index our entire database, and with that, when everything is indexed and we can quickly look up a duplicate, like if something is duplicate of another post, we can already do something. For example, we can remove duplicates, or we can contact the writers by emails, sending emails, or do something similar. And we can evaluate if our simple method of just indexing, like with a search engine, works and useful for the user. And if it is, then we can iteratively improve on it, make it better, and pick up the next most important thing, like think how we can make our communication with the users better, how we can tell them that, hey, don't write duplicates, or how we alert the writers of the original post, like, hey, it looks like your content is being duplicated, and things like this, but only after we have an index built. So this is what I use for solving problems. I think this is a pretty useful method.
Hey, thanks for listening to the HackerNoon podcast. I'm Natasha Nel. This has been a production of HackerNoon.com. See you on the internet.